Today's lesson combined a lot of different things together. So one of the things we talked about a lot today was the word zeros. Remember, a zero is just another word for x-intercept, which is another word for roots, which is another word for solutions. And every time it's asking for x-intercepts, roots, zeros, or solutions, all it's wanting to know is where does the graph cross the x-axis? Or if you're looking at your table, where do you see 0 on the y-side? So for example, in this problem, when I look here, it crosses the x-axis at -2. And at +2. So in my table, I would see zeros when I see -2 and +2. So wherever those zeros are on the y's, that's where your x-intercepts, roots, zeros, and solutions are. The other thing we talked about a lot today was our y-intercept, which in this case is 1, 2, 3, -4. So our y-intercept here is the ordered pair 0, -4. And we also talked about our range. So remember, our range, we read from bottom to top. That's how we read our range. So the bottom of my graph for this problem is down here at -4. So my range is going to be y's that are greater than or equal to -4. And it's greater than or equal to because the graph is above this line that I drew at -4. So it's important to note that not every graph has the same number of zeros. Remember, just as a refresher, zeros are the same thing as x-intercepts. So if it's asking you how many zeros, it's asking you how many times does this graph touch the x-axis. Well, it's different for different problems. So for this particular problem, the first one here, I have a graph. It touches the x-axis once, twice. So that tells us that this has 2 zeros. If I look at my next graph, this graph never touches the x-axis, so it has no zeros. We don't want to write the word zero there, we actually want to write that there are no zeros. And if we look at our last graph, it touches the x-axis once at this point right here, and so it would have 1 zero. And all of your parabolas, all of your quadratic equations are either going to have 2 zeros, no zeros, or 1 zero. Those are our only 3 options. So I have this graph, y equals x squared minus 5. I've gone ahead and graphed it, which you're going to need to as well. In order to figure out all this information, like you've got to figure out on your homework, you need to graph this. So here's my graph. It asks us, first of all, how much did it shift? Remember that we are comparing it to the parent function, which is y equals x squared. Y equals x squared, if you'll recall, is going to be a parabola that looks roughly like this. This is an approximation here, but that's roughly what it's going to look like. And if we're comparing it to that, well, this particular graph, the parent function, has a vertex or a y-intercept at 0, 0, and now our graph has a y-intercept at -5. So that tells us that our graph shifted down 5 units. So it went down 1, 2, 3, 4, 5. Notice I skipped 2 lines here, and that was on purpose because it told me that this was 0 and this was 2, so that tells me that 1 is here in the middle and this is 3. Then it asked me for my vertex. So my vertex is going to be the lowest point on my graph, which is this point right here. It is going to be the ordered pair 0, -5. We also knew that it shifted down 5 because if you look at the -5 that's here in the equation, that's going to tell us which direction and how much the graph is going to shift. And that's also going to affect our vertex for this problem because there was no horizontal shifting. It also asks us how many zeros. We'll recall from what we just finished on the previous slide that our zeros are where the graph crosses the x-axis. So that's 1 twice. So this particular graph has 2 zeros. And then it asks us for our range. Well, our range is going to have to do with our y's, and we've got to either find the highest point or the lowest point on our graph. In this case, we're looking for the lowest point because that's what it has, and my graph is above that point, so it's going to be y's that are greater than or equal to -5. Remember that if your parabola opens down, your range is going to be y's that are less than or equal to whatever this number is right here, wherever the vertex is, whatever that y value is, because the graph is below it, it's going to be less than or equal to that same number. If your parabola opens up like this one, then your range is going to be y's that are greater than or equal to some number. And this number is whatever this bottom value is here on our graph, because our graph is above that point. So this is what our range is going to look like every time. Either y is less than or y is greater than or equal to some number. If I have the graph f of x equals x squared, and I know that g of x equals negative 1/3 x squared minus 4, and I've got to figure out what all happened here. I've got to look at every piece of this. So let's start off with that negative sign. So the negative sign, the first thing that's going to do is that's going to reflect the graph over the x-axis. So because I'm making it negative, that tells me it's going to open down. The next thing I'm going to look at is my 1/3, I'm sorry. So 1/3, that goes back to what we learned last class period. 1/3, there's not inside parentheses, so that tells us it's a vertical something. Vertical is normal, so it's a vertical compression because it's less than 1. It's a vertical compression of 1/3. And then lastly, we look at our minus 4 here. And this minus 4 tells me that my graph shifted down 4. So it tells me my graph shifted down 4. And if I have the graph, or the equation, f of x equals 2x plus 1, and it tells me that g of x equals f of x minus 3. What this minus 3 means, notice again, it's outside the parentheses. So what that means, this minus 3, is that my graph shifted down 3. Well, if my y-intercept was at positive 1 and I moved it down 3, then my y-intercept is now going to be at negative 2. So my new y-intercept is going to be negative 2. So that tells me that my new equation, my new g of x, is going to be 2x minus 2. It's very important that you note that this 2x did not change because we did nothing else to the graph. We did not shift it or anything like that. We just moved it down 3 units because there was a minus 3 here.